Ever been to a rock concert? Right before it starts, what happens? Right before it starts, what happens? What? Kanan? Fog machine. Okay, that was Zach. I didn't say that. That was Zach. I'm not going to tell you the last name, but that was a boy named Zach who said that. All right. So, why do they turn on the fog machine? Does anyone? What?
Dramatic effect.
No. Without that fog, all those millions of dollars of lights that you would see the light and where the light is falling, but you would not see the shafts of light. So in order to see the shafts of light, you've got to have particles in the air that can reflect the light. If not, all you would see is it lit, and over here you would see where it landed. It would be like a spot, like a spotlight. What they're creating in the air is a colloid. That is why some mornings, like a couple of mornings ago, it was foggy, right? Every time you passed a light, could you see the light, the street lamp going like this, the light from, that was because the air was colloidal, a colloid. There were particles, there was water in the air. Normally, on a dry morning and it's dark, you see the light here and you see it reflected off the surface, but you don't see it in the air, do you? All right. So water mixtures are classified according to the size of the particles dispersed in the water. What are the three classes called, and what distinguishes one from the other? Suspension. Very large, easily seen particles will disperse when mixed, but eventually settle out. If you drink anything that says shake before using, it is a suspension. What are some examples of that? What are some things that you have to shake? Kanan. Okay, Sierra. Yoo-hoo, very good. If not, the top is going to be kind of milky, watery, and the bottom is going to be real thick. Okay, Ray. Okay, yeah, the creamer, you mean? The what?
You can buy a little bottle.
Oh, okay, and you shake it. All right, and that's a suspension. Yes, D, yes. Orange juice, very good, because it'll settle out. Yes. Yes, they always, there's a label there that says shake before using. Bobby. Yeah. Okay, if it says shake before using, that means it settles out. That is a suspension. The molecules are so big that eventually they settle out if you leave them alone. So if you want them back up, now here's one that no one said. That's probably because you don't think about it anymore. Milk. Do you ever shake your milk?
I've never done
Chocolate milk is definitely a suspension. But back when I first started teaching, every kid shook the milk. You know why? Because their parents always shook the milk. You know why? Because their parents always shook the milk. You know why? Because their parents always shook the milk. And if you didn't shake the milk, that first few drink was going to be awful. And the last few drinks was going to be really, really thick. Milk from a cow settles out. If you get milk from a cow, there's going to be thick parts and really thin parts, and it will settle out. So back at the time of your great grandparents, whenever they had milk, they had to shake it or else it would taste really, really bad. Now in the 1950s, they came up with a process called homogenization. And still today, if you look at your milk carton, it says it's homogenized. What that does is it breaks these big giant molecules that settle out into teeny tiny ones that never settle out. So the reason why your grandparents shake the milk was because if their parents didn't do it, then it would taste bad. So they would see their grandparents, their parents doing it, but they didn't have to do it. So you had several generations that little by little eventually stopped doing it because back then you had to shake the milk. Yes, yes. That's a suspension. Colloid is in between. The molecules are big enough to reflect light, but they're too small to settle out. So they're big enough to reflect light, to be seen, but they're too small to settle out. Milk can be thought of as a colloid now. And then a solution, the particles are so small that they'll never settle out and you can't see them. The particles are so small that they'll never settle out and you can't see them. So when it rains, you kind of like have a suspension. When it's foggy, you have a colloid. When it's neither, you have a solution. When it's raining, you have a suspension. When it's foggy, you have a colloid. And when it's neither, you have a solution. Okay. So if you could see milk under a microscope, guess what that's whole milk. Big old chunks of stuff. Big old chunks of stuff. You can see. So how can you tell a colloid from a solution? It's called the Tyndall effect. When you can see the shaft of light, that's the Tyndall effect. So in a rock concert, they get all that fog into the air in order to be able to see the Tyndall effect. See the laser going through? Colloid, Tyndall effect. Tyndall effect. If the laser, if you could not see the laser, then that would be a solution. If you would see the laser come in but not come out the other side, suspension. So let's read one more. There it is. You see the laser going through. What is it? Colloid. You see the light? You see the light? No. You see the light? Yeah. So colloid, solution, colloid. All right. So make a drawing like this. 3 jars. One is full of chunky stuff. One is filled with tiny little particles. And one you can barely see the particles. Okay, so a suspension is made up of great big particles that eventually settle out. A colloid is made up of medium-sized particles. And a solution is made up of teeny tiny little particles. But here's the key. Let's take a laser and shine through it. A laser will enter a solution and come out the other side. Why? Because the particles are too little to reflect light. They're too little to reflect light. Okay, the laser will enter the colloid and pass through it. You can see it passing through. You can see it passing through. And then finally, we'll enter a suspension and never come out the other side. It gets absorbed because the molecules are so large. The molecules are so large that they will be absorbed. You think you got solution, suspension, colloid?